Welcome back, everyone. Looks like we survived our first exam. I spent about 8 hours yesterday, so it took you an hour to take it individually. To grade them, it's taken me over 8 hours. So I'll have those back for you on Tuesday. I'll have the scores actually posted tomorrow. So look for those. Um, kind of a mixed bag. One thing I did notice, some were having difficulties with the differentiation. And so remember, all we know so far is to bring that exponent down. And maybe it was actually the algebra, so with negative exponents. So we'll try to keep reviewing those as we go forward. I did open up 11.1 and 11.2. There were many of you had it finished, some didn't, but those are open through the weekend. So if you haven't finished them, I strongly encourage you to do so because that will give you practice on those differentiation rules, which is going to be helpful because as we go into it now, we're kind of doing we're taking the derivative with sort of some algebra involved. There's sort of mixing around. So now we get into things like tonight, the product and quotient rules, or something called a chain rule. But it's all when functions are kind of a function inside of a function, functions being multiplied. How do we go about getting that derivative? So again, we'll have your results back. I did do a homework update. I think I did it today. I can't remember. But recently, either today or maybe I did it last night. I will do it again at the end of the weekend. Again, those other the 11.1 and 2 are still open. So we'll move forward. Also, the homework's 10% of the grade. The quizzes are 15% of the grade. So together that's 25%. The quizzes were important to at least have attempted it. There was a few of you didn't. If there was a reason, contact me and let me know. If you at least attempted it, there was mostly 30s, 40s, and mostly 50s. I turned them all to 50s because there was a couple of the questions were a little bit more complicated because of last time than they needed to be. So anyway, if you had at least taken it, you've got the full 50 points, which is like 5% because there'll be 3 of those for each of the tests. We'll have something on the final, but we won't have any points. So we'll just keep moving forward. Any questions as we sort of dive into the next pieces of information? Doing okay? All right. So I've got this. See, it should be, yes, it's available. So there's our pacing calendar. And remember, it's just to try to sort of a suggested pacing. If you can stay sort of on track, you should be fine. I tried to get it where there are weekly due dates of, I think it's Tuesday. I think I've got Tuesdays. Tuesday's been our standard due date, has it been? I moved it, I think I did. So again, if you had questions from the previous week, you could still get help at office hours. So there'll be a Tuesday due date. Again, it's not set in stone. We can move it if need be, but again, the best thing is to try to keep on track because as we start getting into things, we're picking up new types of differentiation and such, and a lot of it relies on the older stuff. So we can't, when we're doing something called the chain rule, which we'll see what that is, if you've seen it, a lot of times within this, there is the product and quotient rule. So if you don't have this, it's really hard. You're going to find some problems you really won't be able to do without that. And then once we get into here, we really need this, so it's really stuff that's going to build on itself. So as best as you can, try to stay on track. Also, as you move forward, sometimes you don't understand, like the chain rule, it's by moving forward that you actually get to understand it. So I'm not saying you have to feel like you have to master each thing, but try to at least keep on track so you're exposed to it. So as you go forward, it'll start making more and more sense. Okay. So that's there, kind of our pacing calendar. And then what I do underneath here is I'll put, so there's a slide section, I'll put our recorded lecture today. We'll go into this, and then there'll be one for Tuesdays and so forth. These lectures for chapter 11 and 12, those are from a previous semester. I don't even remember when it was. But they're there, and again, but just kind of a grain of salt. They have changed what homework problems they're assigning. And from what I can tell so far, it's with less of a focus on the algebra part. They're trying to simplify a bit. So you'll get, maybe in some of those lectures, you'll get things that are more complex, or more challenging. But what we'll be covering is hopefully a little bit more straightforward. Okay. So basically, we're still dealing with a derivative. And what is a derivative? There's a couple words. It's a slope of a tangent line. So a tangent line goes through a function at a single point and kind of, is a straight line off that tangent line. Yes.
Instantaneous rate of change.
And it is a instantaneous rate of change. Yes. So we started off with average rate of change. That's really an algebra concept. You've got 2 points. You get the slope of a line that goes through 2 points. Now we're dealing strictly with that instantaneous rate of change, the slope of a tangent line, slope at that point. It's always a rate of change. And as we get into more applications, we start seeing that we've got a function that gives us a function value, maybe like a profit. The derivative gives us the rate that the profit is changing. We also call that a marginal. So there's another word we've got. Derivative is also, when you see marginal, just replace it with derivative. That's the thing that we got 3, 4 different words, phrases that we use for it. But that's everything, that's what we're doing. So rates of change. So now we're going to take a look at sort of what I said. This is a little simpler. We won't go to the binomial, but we'll start here. So far, we don't know how to take this directly. So it says find the derivative without distributing. We don't know how to do that yet. That's what we're going to learn. But let's go ahead and do it the old way. So we will use algebra to distribute it first. And then so that we sort of know what the answer is, I'm going to show you, and again, I saw in the exam, some of you actually already know how to do this. Let me see. I think this will keep, my battery's almost gone, but we'll keep going. So what we'll do is first we'll distribute this. So that's algebra. That gives us x to the third minus x to the fifth. Incidentally, the other thing, I'll just kind of bring up sort of, and these are just general, what I notice as I go over the exam, they're very helpful, is sometimes I would see people, you would do something like this and you would be done. You think that was the derivative, or mostly it was like moving it from the bottom to the top, and it was like, oh, I'm done. But you didn't actually take the derivative. You got it ready to take the derivative. So again, when you get them back, if that was your case, take a look at that. We'll keep moving forward with it though. So then how do we take the derivative of this? Good. So I'm going to emphasize that the exponent comes down in front and we subtract 1 from the exponent. That's all we know so far, is how to take derivatives of things with exponents. The exponent comes down and multiplies. So yes, it gives us 3x squared. And then the second term, and we can do it term by term. The 5 comes down, multiplies, subtract 1. So that is minus 5x to the fourth. So that is the derivative. I guess I should, so this is equal. This is not really equal. That was but we do that all the time, don't we? Or we'll just call this y prime. Okay. Now I'm going to propose a way where we can, and this will actually work. So sometimes I say, let's try a few things that might or might not work, but let's just go for what works the first time. So we've got, it's a product, right? Product. Back. So we've got what I'm going to call a first part got a first part and a times a second part. Okay, two functions. This could be f of x, call it s of x for second one. So what I like to do is go ahead and list them out. So here's the first function, it's just x to the third. Here's the second function, it is 1 minus x squared. So those are separate things. To take its derivative, would it make sense that we should take the derivative of each part? Maybe it does, maybe it doesn't, but that's what we end up doing. So I'm going to change colors here. So part of the process is we need the derivative of the first part. And that's going to be, just as we did, 3x squared. We also are going to need the derivative of the second part, and that's going to be minus 2x to the first power, right? Now, does that look anything like what we got up here? Kind of. There's a 3x squared, but we don't have a minus 5x to the fourth, so where does that come from? Well, it comes from the algebra of putting this together. So there's sort of a formula. These are the pieces we need. So as you go through to take derivatives with anything that's being multiplied, you're going to want to kind of, I always like to break it down to these pieces, and then I put it into this formula. When we're doing a product rule, it's going to be the derivative of the first part times the second part, original second part, plus the derivative of the second part times the original first part. Okay, so it's just kind of, this is one of those things you just remember or memorize. I don't like the word memorize. I don't memorize very well, but if I use it enough times, I will remember it. So maybe write it down on a card, and again, you may have to look at it a few times or maybe 100 times, you know, as you're doing your, but once you look at it enough, it will become second nature. So now we just go ahead and fill in our pieces, right? I guess I'll stay in red. Derivative of the first part, well, that's 3x squared, right? Yeah, that's what that is right there. So that comes there. Times the first part, the original first part is here in blue, and since it's got two pieces, we'll go ahead and put a parentheses around it. So that's going to be that, plus derivative of the second part, and that's going to be negative 2x, times the original first part, which is x to the third. Wait. No, well, it sort of is, but if we do the algebra, this could be the answer. We probably want to combine some like terms type stuff, you know, do a little bit of algebra. And if we do enough algebra with like distributing, we will actually count that. Now, when we get more complicated stuff, oftentimes we don't want it distributed. We just want to leave it as it is, because then we can kind of see the relationships. So this is a derivative at this point. I think if something doesn't feel right. Did I do something? Okay, first part, x to the third, derivative. So maybe I just, oh, okay, I see. I'm going to be okay. But it's just, it's still not, because I'm not convinced yet that it's still that thing up there, right? It's supposed to be, if I took the derivative, it should be the same thing as this. And that's where I'm feeling, well, it doesn't quite look there. So we'll do the algebra, okay? And again, this is the derivative, but 3x squared, so we distribute it. That's that one. And then we get minus 3x to the fourth, right? That's that one there. And then this is just a minus 2x times x to the third is going to be minus 2x to the fourth. And notice we got a minus 3x to the fourth, a minus 2x to the fourth. When we combine those, we get the minus 5x to the fourth. So now they match, and we feel that, hey, this method, whatever it was, looked like somebody made it up, but it works. So it must be giving us the correct derivative. And that's kind of how we start, or mathematicians start. They explore these kind of things with simpler things. Now, if this was on an exam, or if I need to take this derivative, I think I would just distribute it and do it that way. That seemed a lot simpler. But the reason I took the time to do both ways is to kind of to explore that this might work if I've got something more complicated up here that, maybe I got three things being multiplied, and that might be more work than it's worth. Or at least two things, I got two trinomials and stuff. So that's why we do it. So that's basically today's lesson, or half of it, is the product rule. So when we've got two things that are multiplied together, and we'll start with two, we could do with three, but it does expand, and it'll work with three or four, however many, but two's enough to start with. Gets us most of the way we want to go. And this is sort of what we're going to end up with. Okay, we're going to do a few examples to test it out, get used to it, and that's what the homework is several problems like the fact, actually, this is a homework problem. Now, you may have a different number here. That's went from the homework. When you see the red, that means that's the randomized number, so you might get 5 in there or something else, but you'll basically get the same problem. Yes?
So in what scenario would you use the longer way versus the initial way, just the quicker way?
Good question. Maybe when we have something like this. Okay. Now, FOIL is still maybe not too bad, but certainly if we had triple, and there's going to be times that we will need to use it. Yes?
So on the test,
Well, they probably don't blow but we probably won't give you something this simple on the next test. So what we'll work towards is we're going to be giving you more complicated ones, but you could use any one. So because I saw some people, again, they use the product rule on the test one instead of foiling it out. They still got full credit. If I caught it, if I didn't catch it and I marked it wrong because it wasn't what I had, let me know. But yeah, you can use any method that you want. I stand by that. I don't care what anyone else says. So the methods, it's not about the methods, it's about getting to the right answer. So on this one, and again, it's going to be up to you to decide whether you want to do it one way or another. But what we're doing is getting some practice, because there's going to be some problems that we're going to be coming up with where we actually have to do it. Because we're now going to remember, but we've got some other functions lurking in the future. So we've been doing x to some power, the power rule, power stuff, but what other kind of functions are there? There's exponential, e to the x. There's natural log. And so if those of you in finance, you use those a lot, economic stuff. And so for those, because they have a different type of, they work differently, so the algebra part we will have to use this. Okay, so for your homework, again, you may be able to get through it faster by just distributing and go, but what I encourage you to do is actually practice the product rule, because it's simple enough that you'll start to see how it works, the pieces, and then when it gets more complicated, as long as you follow this thing of just write out the first function, second function, take their derivatives individually, those aren't anything new, and then put them together, you'll always be fine. Okay. So we're going to follow through with this. So again, I kind of like to label first function times second function. Okay, so we got two pieces, very clear to see there's two parentheses. So I'll write them over here. My first function is 2x squared plus x. My second function is x minus x squared. And then what do I need? I need some derivatives in here. And these are just like the derivatives we've been taking, some and difference rule type things. 2 times 2 is 4. 2 minus 1 is 1, so I get x to the 1 power. And the derivative of x is it's x to the 0, but there's a 1 in front, so whatever's in front. So whenever we have an x, remember we'll subtract 1, we get x to the 0, so that goes, but there is that part here. And again, I saw a few times that was an issue. on the exam of, so just kind of catch yourself being able to take derivatives. And that's why I said, go slowly enough that you can, because I'll tell you, at least for me, that's where I would make my mistakes, is in these sort of simple parts, and then you put it back together, and if you don't have the right stuff here, when you put it together, you don't have the right ingredients, you don't get the right answer. Second part, derivative of x, 1, derivative of x squared, 2x. Okay, so those are our 4 pieces, and I'm going to rewrite this, and this is how I say I get to remember things, is each time I do it, I'm going to write it out. So I have it on my little card. That's at least how, when I first did it, I could look at it, but I'm also going to say, okay, product rule, y is going to be the derivative of the first part times the second part as it is, plus the derivative of the second part times the first part as it is. Okay. Derivative of the first part, 4x plus 1. Second part as it is, unchanged, x minus x squared. Plus derivative of the second part, it's down here, 1 minus 2x times the first part, unchanged. Now, do we have to FOIL that out? Sure hope not. Because if we, why should we just FOIL it out at the beginning? So that's where you'll start to like this. Is now I can just leave it like that. Because if I need it, I can plug that in a graphic calculator and I can get values for the derivative. But I got something I can use. There's no need to multiply it all out. And if WebWorks says something different, like you have to reduce it, just tell it Little Crow says I don't have to. Don't worry about it. You can leave it like this. I'll accept that as an answer. And if I have to manually overwrite it, I'll do it. But this is actually how I prefer it, because then you start seeing the pieces, especially if you carry through and use the colors and stuff, you see what's what. But that's how we can take those derivatives. And again, this is an applied class, so what we need to be able to do is take that derivative in a way so that we can then use it. And now we can use that. We put this in a computer and have it model what the derivative's doing. Get a table of values. And again, we've got 2 functions. Remember, this is going to give us what? What kind of values does this give us? Derivative always gives us a slope, a rate of change. It tells us where we're going. That sort of tells us where we've been. It sort of does tell us about the future, but it tells us values. So this might be a profit function. This would tell us how the profit's changing. Okay, and so then 2 different types of analysis. So far, so good? We're doing okay, yeah. So far, again, as far as taking the derivative, nothing really earth-shatteringly new. It's just now we've got sort of this process. I'm going to bring this one up. This is actually in the homework. And again, you'll get different numbers for where the red is. So, but if you want to, this is an example. I can't remember. This was number 9 one time. I think it might be number 9 still. Anyway, what we can see here, I usually don't like to read a question until I try to understand it. I see some functions. There's that. I like to look at those first. So there's this function. It says units per month. I guess that got cut off. So you'll see this T minutes after its introduction. So this is monthly sales. Okay, so kind of, and then the second one, P, is a price they charge, dollars per sound systems, T months after introduction. Because how many, if you're in supply chain or even supply and demand, right? Usually a new product comes out, it's got a higher price, and then as more people adopt it, price will go down, which seems to be happening. So they've got a function that will sort of model that over time. But sales, maybe they go up, maybe they go down, but it's going to follow that curve. So that's the amount of sales. If I take the price I charge for something and how many I sell, what do I get? I sell 100 things at $5. If I multiply those, the revenue, I get not profit, because this doesn't deal anything with cost, but it gives me the revenue, right? And so that's really with those two functions, when we multiply them, we're going to get the revenue. Individually, their number of sales, which is great to know, and the price at a given time. But when we multiply them, we'll actually get projected revenues. And when we take their derivatives, remember this is the rate that sales are changing, this is the rate that the price is changing. Eventually, we're going to want the rate that the revenue is changing by using the product rule. Okay, so it actually breaks it down into steps for us, doesn't it? So here's Q. Let's go ahead and put that there. So that's really I guess we could call it our first function. And so what is Q prime going to be? That's not G prime. Say that again? 6,000. Oh, good. Because 6,000 has a variable next to it. So the 1 comes down 1 times 6,000. Good. So it's not a constant. 6,000 is not a constant. It is a coefficient in front of the t variable, t to the first power. And I always put the t to the first power because, again, that helps me see there is a variable there. Or there's an exponent there. Otherwise, I think there's 0 there or something. And that's, I might just say, oh, that's a constant. It's gone. But it's not. It's t to the first power. So I do 1 times 6,000 is 6,000. T to the 0, that is 1. So that's what we're done. And then the 2 comes down. So that's 60 times 2 is 120. T to the first power now. That's our derivative. So that's what goes in here. Right. And then the price function we'll do over here. Well, it's kind of our second function. So notice how we're getting all the pieces anyway. 3,000 minus t squared. So now when we take the price derivative, though, what happens to the 3,000? That's 0, because there's no variable next to it. So that's a constant, so that's 0. And so the derivative of the price is just going to be minus 2 t to the first power. Okay, so I can put that over here. Then find the rate of change of monthly revenue 5 months into the introduction. So in this one, we want to do a product rule, but we're actually going to evaluate it at a particular value, not just X. We'll put 5 in for X, right? So how do we do the product rule? I guess we'll call it R for revenue, right? That makes sense. R of T. And we don't need the revenue function itself. We could. The revenue function would be Q times P. I guess we could write that. Q of T times P of T. So this sort of emphasizes that we are using a product rule. So the derivative, because that's all they want, they don't really want they didn't ask for the revenue itself, they want the rate of change. So where do we go? So see if we can remember what goes first in a product rule. Derivative of the first, right? So maybe I'll put my little cheat sheet down here. So derivative of the first times the second plus the derivative of the second times the first. Okay, so we're calling the first functions Q, so we'll put that first. So we'll put this one first. It's going to be 6,000 minus 120t. And so that's a derivative of the first one. We multiply by the second one unchanged, the original second one, which is P of t. So that's 3,000 minus t squared. So there's our first part. Plus, there's our plus here, the derivative of the second part. That's nice little simple negative 2t times the first part unchanged, right? First part unchanged. That's why I have to write it out. Remind myself. First part unchanged, the first part unchanged, that's the 6,000 t minus 60 t squared. And that's the derivative, okay? But that's not the answer they want. They want to know what is the rate of change when t is 5 months. So what do we do with the 5 months? We plug it into that thing. But at least we don't have to algebra it out. But it's not pretty, is it? No. But so what we want is r prime of 5. So I'm probably going to need some help with this. So it's going to be 6,000. See if I can do 5. Well, I'm going to write it out because I just want everyone to, otherwise it'll be hard to see what's happening. So 5 times 120. So if someone could get that. And then we're going to multiply that by 3,000 minus 5 squared, which is 25. So then we're going to add, actually, we could take this negative. I usually don't like to have a plus minus, just for, but it's up to you. Take this out. Let's just clean this up. Here's a negative, because what I end up doing is I end up dropping the negatives for some reason. 2 times 5, and then we've got 6,000 times 5 minus 60 times 5 squared. We're going to get some big numbers in here, aren't we? But then we're subtracting some things from some things. So, but that's what we got to do. Yes?
So why did you not put the negative 2t in parentheses before?
Because it looks like, to me, it looks like one thing. If you'd like to, you can. And maybe that's a good thing, because otherwise it looks like, yeah.
Because I thought you were going to multiply it by everything else.
Yeah, so for me, when I have this 2t, since I have the parentheses on the second part, I know to distribute it. But it might be good practice, just go ahead and put everything. But sort of if it's a single term, I generally don't, but it's actually probably a good idea to do that. Causes me some problems. That's why I lose some things, sort of fall out. But yes, it's got to distribute over, and now so I don't know. What do we get? We get that's 120 times 5.
600 minus 6,000, 5,400.
5,400 here, and then 25. So 3,000 minus 25 will be 2,975. So that's going to be a big number. And then we're going to subtract 10, 2 times 5. 6,000 times 5. How much? 30? Okay. I didn't know if you were going all the way for me, but 30,000. And then 5 squared is 25. 25 times 60. Again, in reality,
1,500.
what's that? What's
1,020.
1,020?
You got to fact check me.
Yeah. What I do is I just put in the calculator all together, because otherwise, So I'll do 6,000 minus 120 times 5, parentheses, 3,000 minus 5 squared, parentheses, oh, I'm still having problem with my, on my computer's calculator. And then I'm gonna minus, I'm gonna go ahead and just keep that as 10 times 6,000 times 5 minus 60 times 5 squared. And I come up with 15 million. Whoa. It's a good business to be in. 15,780,000. 780,000. Did I get that right?
Weren't we doing it 5 months after? So wouldn't you have to divide that by 5? Or did you do that and I missed it?
Find the rate of change of monthly revenue 5 months after the introduction of the sound system. So t equals 0 is the introduction. 5 months after would be t equals 5.
Oh, that's after.
Yeah, so this is after. We're using the derivative already, so this is the rate of change in the 5th month. So we're increasing by 15 million. Maybe we're a big company. I hope. That's a huge company. We'll buy one a little stock in that thing. So when t equals 5, and again, I mean, yeah, there's companies out there that, 15 million's pocket change for them. Again, this is just the increase in the profit. It's not the profit itself. If we wanted the profit itself, what would we do? Oh yeah, if it's not the profit. If we want the profit, we need the cost. If we wanted the revenue, so this is the rate of change of the revenue. If we wanted even just the revenue, we would go to the 2 original functions and just multiply them. That would give us the total revenue. But this is 5th month, we're actually increasing our revenue. And that's by decreasing our price, but oftentimes that helps more sales, right? So sell it at a cheaper, you sell more for less, you still might end up with more. Yeah.
So what's the answer to the part that's left blank?
Oh, let's see. It's so find the rate of change. So that's the 15 million up here too. And then the last one, they just kind of want you to put it in sorry. I read ahead, and since I already wrote it down, why should I have to write it down twice? But you have to write them twice, right? So that's the rate of change, and then this is just kind of put it in a sentence. Does that make sense? See how didn't necessarily make it easy, but it made it doable. We could take a derivative of something that's a product without having to distribute it out or FOIL it out. Again, maybe that might have been the easier way to do it. But again, we're going to get to ones where it's either not going to be easier or it's not going to even be possible to do that. We're going to need to be able to apply the product rule. Okay? We good? Yes, sir.
Well, first of all, how did the 60t squared become to 120? Not in the beginning.
Oh, up here, 60t squared. When I take the derivative, the 2 times 60 is 120. And then I subtract 1 from the exponent, and so yeah, so the 2 comes down, 60 times 2, subtract 1 from the exponent, okay? And that's the part is you want to practice these enough so that becomes second nature. Because again, we're going to be doing this. You want to practice the product rule enough so it will become more second nature. It's okay to have some notes and follow along and do it, but just do it enough that it's there. Because again, as we move forward, we have some other things, and like I said, we got this thing called the chain rule, has some in time. Sometimes we're doing a combination of stuff. We're doing a product rule with a chain rule, or a chain rule with a product rule. And so it's like, and again, if we keep all the pieces together, we can do it. But we've got all these pieces going around. Okay, so that's half the lesson. Which is good, because we're more than half the time, right? So, product rule is simply the derivative of some function. We'll go ahead and call it h of x if it's a product of two things. So we'll define h of x to be two functions, f of x and g of x. So when we take its derivative, again, derivative of f of x times g of x plus, I like to switch the order as I go, the derivative of g of x times f of x. Okay? So it's just kind of to formalize. That's what you're going to, that's the new part to it today. We're going to see when we get to the quotient rule is something kind of similar. So we're going to build off of this. But now we're going to do a derivative without dividing it. Okay. And again, I'm going to do it both ways so that we can see that we match out. Now, when we use the quotient rule, we might not get it to look exactly like what we could do if we simplify first. Okay. And I haven't worked this all the way out, so I'm not sure, but we'll just go ahead and give this a try. I think this one works out all right. So what we're going to do is first do some algebra. We'll divide x squared by x to the fourth minus 3x to the fourth. So this is all algebra so far. So this becomes 1 over x squared, right? And this stays minus 3x to the fourth. So let's do one more algebra step. Let's get these so that they are negative exponents, right? X to the minus 2 minus 3x to the minus fourth. So that was all algebra so far, right? So we okay with that? Just distributed the division. And so we've got this. Now we're going to take its derivative. So I'll do a y. Derivative, negative 2, right? The exponent comes down in front. So we're going to get a negative 2x. Subtract 1 from the exponent, so we get, what's our new exponent? Negative 2 minus 1, negative 3. Again, that's where some of the confusion can come in. Negative 4 comes down in front, so negative 3 times negative 4 is positive 12. We subtract 1 from the exponent, we get negative 5. Okay, so that is the derivative. And again, in my estimation, this would be the easiest way to do it. I would go ahead and do it this way. However, we want to learn how to do a quotient rule because there's going to be times where that's all we can do. We're not going to be able to, and we get there very quickly. Okay, and so for the same thing, we've got a top part. I guess we could do n for numerator if you want, but I like top. And we've got a bottom part. So T for top, B for bottom. Use whatever letters you want. But we're going to do basically the same thing. We're going to take what is the original top. It's just x squared minus 3. What's the original bottom? It's just x to the fourth. We're going to need some derivatives, right? Because that's what we're doing. So we'll take the derivative of the top part, and that's going to be just 2x to the first power. Is that right? Okay. And we'll need the derivative of the bottom part, and that's going to be 4x to the third. Good. Okay. And we're going to get a similar thing, but it's going to be a little different, right? It's going to be a little different. We take the derivative of the bottom part. When we had things in the bottom, this was x to the fourth. What happened to that exponent when we moved it up? We got a negative. So here's the quotient rule, is we have the derivative of the top times the bottom unchanged minus the derivative of the bottom times the top unchanged. But we still have a denominator, so what we get in the denominator is we get the original denominator squared. And if you think of this, the denominator, if you moved it up, you could think of it as to the -1 power. And when you subtract -1, you get -2, and move it back down. So that's where that comes in. But this is the full quotient rule. Okay, similar to the product rule, but it's got this extra because it's got the quotient. You square the denominator, and it's a minus instead of a plus. Okay. So let's see if we can do this. So the derivative of the top part is 2x. Maybe I'll use some color because we're getting so much going on color, times the bottom part unchanged, so that's our x to the 4th, minus the derivative of the bottom. So the derivative of the bottom is 4x to the 3rd. And again, you may say, oh, I'll save some time and I'll just do it as I go. That's where it's really hard, because you're trying to take a derivative and get in the right place at the same time. Especially at the beginning. If you get good at it, more power to you. To this day, I still have to put my pieces over here. Times what? The top part unchanged. And again, I just put this one in it because it's got 2 terms. And maybe, yeah, it's a good idea to go ahead and put this, that we're going to have to distribute it. Maybe I should go ahead and put parentheses here. Again, whatever feels good to you. And then I've got the bottom part squared. So that's going to be x to the 4th squared. So this is going to be q prime. Q prime. Where q is t over b. And we'll just do a little bit of algebra. This first part, 2x times x to the 4th, that gives us 2x to the 5th, minus, let's go ahead and distribute this out. So this negative 4x times x squared is going to be minus 4x. 3 plus 2 is 5. And then I've got minus 4x to the 3rd times negative 3, so I'm going to get a plus 12 x to the 3rd. So remember, this is the answer we came up with. So seeing the 12 is helpful, and this is all over. When I got an exponent to an exponent, what do I do with them? What was that? Multiply. Good. So this is another, get your exponent rules. When we're multiplying x squared times x to the 3rd, we add, but x to the 4th raised to the 2, that's when we multiply. Because if we get those rules wrong, we'll be off, right? So 4 times 2 is x to the 8. Okay. And what you're going to see, so we got 2 like terms. We got 2x to the 5th minus 4x to the 5th. So those we can combine into negative 2x to the 5th, and we see a negative 2 there, right? I'm running out of room here, sorry. So this becomes negative 2x to the 5th plus 12x to the 3rd. And then if we divide each of them by x to the 8th, so that's how we can kind of split it up. What we'll see is we get, so 5 minus 8, right, that's going to give us x to the minus 3. Negative 2, x to the minus 3. And 3 minus 8 is negative 5, so that's going to give us a plus 12, x to the minus 5. Now again, for homework purposes, I would stop about here. You might go ahead and square this one and put it x to the 8th, but you could stop there. The reason I went on is I wanted to show that when we were done and we simplified it, we got the same thing we did the other way that we kind of felt pretty good about, because we did the algebra, we simplified first, and we know how to take that derivative. So this is a new process, but I want to show you that they connect. They give us the same answer. And usually in math, if you use two different processes and you get the same answer, it means you can use them both. Not always. There's a few ones in there that it worked there, that was a special case, but this is not just a special case. So we've got hundreds of years of people doing this. It works all the time. Yes? Yeah. You know, if it says simplify, sometimes you might want to, but what I'm interested in seeing is that you know how to apply the quotient rule so that we get the new function and it's usable to us. And again, as you see a lot of it, it's, well, find the derivative at 5. So then we plug in the 5 and we've got something we can plug it into now. And so there's no real reason necessarily to simplify out. Yeah. So that makes sense. You see how the two are connected. So that's why we do the quotient, the product and quotient rule, because they're so similar, and multiplication and division come in quite a bit. So division, any type of thing you can think of where we're dividing things, finding averages or something, that's where we're going to use it. This is a similar one to the homework. So here's another one where, again, if we follow the process, it's not too bad. And this is one we can't really simplify it down so it doesn't have a fraction. At least not easily. Or even doable. Okay? So again, we'll just label this as the top part and the bottom part. So the top part, square root of x minus 8. Bottom part, square root of x plus 8. Just remember we need some derivatives in here. So I'll change colors. So the derivative of the top part, can we do the square root of x without changing it to 1/2? Maybe not quite yet. Okay. It might not be safe. So we'll put our little helper out here. It's really x to the 1/2, and that's not the derivative, right? That's just the algebra of rewriting it. So we're going to take the exponent, bring it down in front, and then subtract 1 from it, or 2 over 2. So we're going to get 1/2 x to the minus 1/2. And again, if you want to write that as 1 over 2 square root of x, right? When we're done with it, this is sort of, the text says to kind of remember it. So if you, because we do it quite a bit, so you could just, maybe it's easier to write that way. But, and then what's the derivative of 8? 0. So that's gone. The derivative of b, and what you'll see is this is going to be the same thing, isn't it? It's just square root of x, and then 8 is 0. So it's going to be 1/2 x to the minus 1/2. Now we just get our template out. Okay, quotient rule. So the derivative of this function is going to be the top part derivative times b minus the bottom part derivative times t, unchanged, all over b squared. And so then we just put our pieces together. Maybe just for simplicity, I'm going to write the derivative of the square root of x as this, right? Just so it looks prettier. And then I multiply it by b unchanged, the original b, minus derivative of b, and again I'll write it in this sort of nicer cosmetic form, times the derivative, or sorry, times t unchanged, the top unchanged, which is x minus 8. That's all going to be over the b, which is the bottom one, square root of x, did I get that, plus 8, squared. Anyone want to simplify that? I don't. And we don't have to, right? So that's the thing, is now we've got something we could use. If they needed a particular value, we can plug in our x and we can get our calculator to do it. But we are done. This is the derivative, as far as I'm concerned. And again, I don't write the program. I don't even choose the questions. So If it asks for something else, just let me know. If you don't want it, I accept these type of problems, these type of answers. If the system doesn't, I'll overwrite it and we'll go from there. We'll still get you your full points. Okay. I mean, you could write it over, because it got a common denominator. So there are some things you could do to make, if you're going to use this a lot, you might want to make it look pretty, but we don't have to. And the reason especially at this point, I don't want you doing it because I want you practicing the quotient rule, not the algebra of all this other stuff that might get you going a different route. So what's the quotient rule? Again, we get some function h. I don't know why they always use h. And then we've got some function f of x over g of x. What does it look like when we take that derivative of h of x? It's the derivative of the first function on top times the bottom function unchanged minus the derivative of the bottom function times the top function unchanged divided by the bottom function squared. Okay, and again, put these on a little card. And so that they're right there when you need them. You can look at them if you need to. Every time you do a quotient or a product rule, write it out. It will, and then it'll become second nature. That's the helpful part. Do the pieces, put the pieces together, and we're done. And then but also, as you're doing it, be aware of anything that you are making mistakes on, because they happen, Maybe you have more problems with the fractions, with the negatives, or whatever it is, and then focus a little bit more on those. Take those a little bit slower because I got problems with these. Okay, and we're going to build and we're going to do better and better. So, again, some of you did very well on the exam. Some you might have wished you did better, but we'll all be able to recover. We'll all be able to still get a good grade. And I do that thing. I will examine if you improve, no matter how bad you did on that first one. If you improve, I reward improvement. And remember that final exam, we're going to see the same material again, so I get to see. That's the second way of testing. I don't formalize it because I don't know what the coordinator is going to do, but I always do. I do take a look individually. And when I see progress, and I see, I'm not going to grade you on the struggle. I'm going to grade you on what you're able to learn. Okay? So stick with it. Big weekend, right? I think there's some golf thing going on, and some guys playing flag football. They're playing some other football. None of my teams made it, so I don't really care so much, but anyway. I'm born in Seattle. I'm still a Seahawks, or the Cardinals. I would go either way, but it was kind of like I felt we were battling out for last place with each other. So anyway, have a wonderful weekend. Thank you.
Northern California, right when I went over into Oregon, and then I started seeing all Seahawks.
Exactly, yeah. Just to stay in the family, I got to, because they're all up in Seattle. They've got the flag, that's 12-man flag thing. Yeah. Oh, you're an Eagle fan, huh?
Yes.
Good luck.
I'm really happy.
So my president at the college. So.
Oh, really?
Yeah,
is he from there?
Well, at Scottsdale. I teach at Scottsdale there too. He's a big Eagles fan.
That's good. I'm happy for him. I hope he wins.
Yeah.
I'm Marcos. I'm the one that was emailing you about missing my exam because my car got towed.
Right. Okay.
Where can I meet? Do I come here or do I go to your?
No, if you could come to my office on Tuesday.
Where is it?
It's ECA, which is Engineering Center A building. If you go down Palm Walk, where all the palm trees are, and that road that goes into MU, I'm right on that corner of those two roads.
Okay.
And I'm on the third floor, 339. Third floor,
339.
down, 339.
Thank you, Professor.
You're welcome.
I'll see you.
See you Tuesday.
I have a question. So on the exam, when it asked us for the derivative,
Uh-huh.
I left it like this, but do we still get credit?
Yeah, if it was the written part, I will take anything that's a correct word. Yes.
Okay,
Yes.
thank you.
Thank you, Professor.
Thank you. You too.
There was, one question.
And nobody did, like I said, I'm still working a bit, but nobody did terrible.
You haven't
But
gotten to mine yet, then. That's what happened.
it wasn't that, no. I mean, the thing is, some people get a B and they say, "Oh, that's terrible. I should have got an A or C's." There's a few lower ones, but they're most, it's all recoverable. And mostly it was the ones, they didn't know there's a few that didn't answer half the test. So but if you answered, for those who answered all the questions, I think they can. You'll be
Yeah,
pleased.
one of the things I've been focusing on, because I haven't taken a math class in a while, is we were talking about this a while ago, like the exponent rules, or what to do